Alrighty, today we are moving on to something a little bit more exciting. Well, exciting is as ever in quotes, but today we are going to start with polynomial multiplication. So, if you remember the rules, the exponential product of power rule, I know that you thought you were done with that, but believe me, if I'm not done with it, then you're not done with it. And believe me, and like I said, believe me, it shows up. That rule shows up in the weirdest places. So does the quotient rule, but don't worry. I mean, as much as I can, I'm gonna try to keep it away from both of us. But the product of power rule, if you remember, is if you have a base raised to a power multiplied by that same base raised to another power, then what you're going to do is you're going to add the bases together. Not the bases. Oh my goodness. You're going to add the exponents together. So if you have x, so if you have x times x, you're basically just going to add the little numbers, little exponents together up top. So I bring that up to bring you multiplication of polynomials. So remember, if it doesn't have an exponent, you just assume that it does have one. So here we go. Whenever you have, I don't know exactly how much everyone's gone over with this, but given how I kind of had to go over this with the geometry kids, I will mention this to everyone here. Whenever you have a setup like this, what you're going to do is what's called distributive multiplication. And what that means is that this number here, you multiply to every single number here. And so what that means is if it's written like this, you're basically going to write out 3x squared times 4x minus 3x times 4x minus 5 times 4x. Now the minus comes because that's what this operation is here. If this was 3x squared plus 3x plus 5, then these would both be pluses. But if you have a set of parentheses and a number outside those parentheses, or an expression outside those parentheses, that means that you multiply everything inside those parentheses by what's outside those parentheses, like so. So, um, keeping the product of power rule in mind, what do we get? If you remember back to our exponent days, what do we get when we multiply 3x squared by 4x? Well, 3x squared times 4x, even though it looks like these are two terms being multiplied together, they are not. They are, in fact, four terms being multiplied together. It is 3 times x squared times 4 times x. And because of that, I can group everything together I can group everything together that I'm going to multiply. I can group all the like terms together in order to make the multiplication easier. It gives me 3 times 4 times x squared times x. Now the question is, why can't I combine all of these together? Why can't I just say, oh, 3 times x times 4 times x, and do that and put it all under one big parentheses, and then just solve through the same way that I did with the exponents? Because, I mean, we're combining them with the exponential rules. Why not just do the same thing? The reason is because all of these multiplication operations are being split apart by addition and multiplication. Not multiplication, excuse me, addition and subtraction. Addition and subtraction are basically the great mathematical dividers. If you have multiplication and division, you can basically combine a bunch of different things. You can combine a bunch of different things together into one big operation. You can change things. You can factor things. You can add. You can yeah, you can add in constants, you can remove constants, you can do conversions. Multiplication and division are fantastic. But if you add in addition and subtraction, basically it means that this term, whatever you want to do to this term, it's this term. And then you have a wall. This term, whatever you want to do, it's this term. Then you have another wall. Then you have this term, and whatever you want to do, it's just going to be this term. So by that same logic, that gives me 3 times 4 times x minus 5 times 4 times x. And so, like I said, oh, there we go. So all I've done really is I've broken apart all of the multiplication the same way that we did all the way back in the exponential rules unit that we did, the very first exponential rules unit that we did with, I mean, it's fresh in my mind because I just pre-recorded all those videos. But yeah, all we're going to do now is we're going to combine all the terms. We're going to follow through with all the multiplication and then combine all the terms together. So this first one, so I'm just going to, so this first one, 3 times 4 is 12 times x squared times x. Well, if x to the a times x to the b is a plus b, x squared times x, this is to the 1, x squared to the x is 2 plus 1, which is x to the third. And that's the first term, minus 3 times 4 is 12, x times x is x squared, minus 5 times 4 is 20, x. And there we go. Yeah, that's how we do it. Now this one I put in a bunch of extra steps just to kind of illustrate what it is we're going to be doing. I'm going to be doing the distributive property a little bit more directly. I'm not, for example, I'm not going to draw it out like this every single time. I don't have a problem doing middle steps, of course, because obviously you have to figure out what I'm doing and how I'm doing it. But as far as like breaking it apart and then breaking apart each term and combining like terms, that's not going to happen. So I just don't have enough space for that for every single problem. All right, so number 2, I've got negative 5r cubed multiplied by all of these here. All right, so what that's going to be is negative 5r3 times, oh, that's going to be negative 5r3 times 3r squared plus negative 5r3 times 5r plus negative 5r3 times negative 1. All right. So much the same way that we did over here, I'm just going to go and combine the like terms, but I'm not going to explicitly write it down like I did over here. But I've got negative 5 times 3, which is negative 15. Then r to the third power times r to the second power is r to the 3 plus 2, which is r to the fifth. That's the first term, plus, there's the wall of plus and minus. Negative 5 times 5 is negative 25. So I'm going to turn that into minus 25. Then r to the third power times r, that's going to be to the first power, is r to the fourth. And then I'm going to wait to see whether it's positive or negative. But negative 5 times negative 1 is going to be plus 5. Oh, well, there we go. And then R3 is just left on its own. All right, so again, just kind of walking through what we did. I did the distributive operation, and I broke it apart so that negative 5 was multiplied by each one of the terms here. So 3r squared, then 5r, and then negative 1. And I made sure that, whoops, minus This is why you take a look at, there we are. There we are, okay. Always good to check your work if you can. But anyway, I did the distribution. Negative 5r3 times 3r squared went here, plus negative 5r3 times 5r minus negative 5r3 times negative 1. And then all I did was I resolved what was inside each of these parentheses, and then wrote the term down, and then wrote the resulting term down each time. All right. Next one. Oh, we only have two terms. Sweet. This one's going to be 7m to the fourth times 9m to the second minus 7m to the fourth times 2m. Now you'll notice, unlike with addition and subtraction, with multiplication, we can combine whatever exponents we want. Inside the parentheses, so inside the parentheses, we're restricted. 9m squared minus 2m, that's where it ends. That's where it stops. We can't go any farther than that. But when you multiply it by, a polynomial, and but when you multiply something by the polynomial, it doesn't change how many there are inside the parentheses. It just changes what the exponents are inside the parentheses, and obviously the coefficients too, if it's got one on the outside. But that's a key thing to notice, is that whenever you do a multiplication, especially of just one factor, all you're doing is changing the coefficients and the exponents. So yeah, alrighty. So I've got 7m to the fourth times 9m squared. 7 times 9 is going to be 63. M to the fourth power times n to the second power, in accordance with our, is going to be m to the 4 plus 2, which is m to the 6, minus 7 times 2, which is going to be 14. And then m to the 4 times m to the 1 is going to be m to the 5th. And there we go. That's our final answer. All right, this one, again, just kind of like what the ones we've been doing. We'll just draw out the multiplication distribution. So 5p squared, not to the 5th. 5p squared plus 6p times 4. And so once again, just as a quick review, whenever you see a term out here next to the parentheses, it's 6p times everything inside the parentheses. So what you're doing is you're taking this term times this term times this term times this term. And it's basically, it looks like this. So it's this term times this term, which is where you have here, this term times this term, which is what you have here. And now that we have it in this form, we just multiply through and simplify out. So 6 times 5 is 30. P times p squared is p to the third. All right, and then 6 times 4 is 24, and then p. All righty, we're doing pretty well so far. Let's keep it moving. All right, so I've got 5w to the third times 3w to the second plus, all right, I just did a quick check. This is not in standard form, so again, I just did a quick check. All of our previous answers have been in standard form. This is not written in standard form, so we're going to have to, when we write the final answer, remember that you have to write every answer in standard form, otherwise it's easy points to miss. But I'm going to do the distribution first. I'm going to do the multiplication first, get the final form, then write it in standard form. One thing at a time. You always want to do one thing at a time. No need to mess with a bunch of different steps. 5w3 times 1. And even though this is times 1, And it's a simple step. I know it's 5w3 times 1. It's going to end up being 5w to the third. Just like with when I was just like when I was suggesting with you all how to do the quotient rule, write it down. Always write it down. Write it down to keep track of what you're doing. Write it down to keep track of your thoughts. You can always, excuse me, I apologize. You can always simplify it later, but get it down first and then simplify it afterwards. And then minus 5w to the third minus 4w. Alrighty. So 5 times 3 is 15. W is 3 plus 2 is 5. Plus, and like I said, even though 5w to the third times 1 is going to be 5w to the third, this period here, this time now, this step here is when I'm going to worry about it. Minus, and then 5 times negative 4, oops, yeah. 5 times negative 4 is negative 20. I'm just going to go ahead and switch that to 20. And then w to the 3 times w to the 1 is w to the 4. Okay, normally I would say we're done here, but like I said, this was not written in standard form, so we are just going to write it in standard form before we're done. Now we're done. And I got to remember to tell you all that during the lecture part of this, that all answers have to be in standard form or they will be wrong. And I don't think I'm being too out of line by saying that. All right. A times 4a squared minus 5. All right. I normally wouldn't do this. I normally wouldn't suggest this, but this is such a trivial answer, and this is such a trivial problem. Whenever I say trivial, it's a math term. It's basically it's basically a math term that you run into in grad school or advanced undergrad, where the problem itself is so simple and the solution itself is basically understood that it would be that doing the work is seen as a waste of time and energy. Like that. So in this case, I can eyeball the answer. I know it's going to be 4a to the third minus 5a, because multiplying it through, a times a to the a squared is going to be a cubed, and then minus 5a is going to be a. Like I'm not, even if I can appreciate the fact that for a lot of folks this is new to them, and that for a lot of the students that this is probably the 6th time with this problem here. This is the 6th time they've seen this. But I would hope by now, even with this, they can look at it and say, I think I can probably do this without pen and paper. So if you can't, I apologize. We'll have plenty of opportunities to do other problems, but if just for a quick check-in, you can look at something like this and do it in your head, then you're in great shape. If you can't, again, no big deal. That's why you're in school, is to learn so that you can do it in your head. All right. Next, we've got another one that's not written in standard form. Thanks, fellas. But we can still do the distribution and write everything out correctly. So that leaves me with, oh, all right. I thought my day was going to be over sooner. All right, so I've got 15k times negative k plus 15k times 2k squared. So that gives me negative 15k squared plus 15 times 2 is 30, and then k times k squared is k to the third. Writing it in proper form, that gives me 30k to the third minus 15k squared. Alrighty. Kind of wish I didn't have as good of lighting as I did, because I was perfectly content to finish at number 10. Right. So we have this one. All right. We have this one multiplying through here. Again, we're going to set up the distribution. So I've got x to the 6 times x squared plus x to the 6 times 4x. Alrighty. So this is almost literally the product of power rule. So it's going to be 6 plus 2 is x to the 8 plus x to the 6 plus 4x. I don't have any coefficients I have to deal with, so it's just going to be dealing with the x's. 4x to the 7th, because 6 plus 1, 7. Oh, there we go. Okay. It's starting to warm my heart whenever I see a problem written in standard form, because it means that I don't have to throw in the extra step. But, all right. So again, we're going to set up the distribution. So I've got 5a to the 5th times 3a squared minus 5a to the 5th times 2a plus 5a to the 5th times 3. All right. Let's see, 3a squared, 2a, 3. All right, for some reason I thought that I was missing something. So 5 times 3 is 15. A to the 5th times a squared is a to the 5 plus 2, which is a to the 7, minus 5 times 2 is going to be 10. A to the 5th times a to the 1st is going to be a to the 6th, plus 5 times 3 is going to be 15, and then a to the 5th. 765, we are in proper form, and there we go. All right, 15, there we go, now it's legible. All right, last one on this page. Again, we have it in standard form, so that it doesn't take much to make me happy, but it's in standard form, so now I am happy. So I've got 6k to the 4 times k squared plus 6k to the 4 times 9k minus 6k to the 4 times 3. Alrighty. Now that we have the distributive set up, I'm going to go with 6. 6 is going to carry through, so we're not doing anything with that. K to the 4th times k to the 2nd is going to be 4 plus 2. It's going to be k to the 6th plus 6 times 9 is going to be 54. K to the 4th times k to the 1 is going to be k to the 5th, because 4 plus 1. And then minus 6 times 3 is 18. And then nothing changes with k to the 4th. And again, I've got 6, 5, and 4, so the standard form looks good. All right. Whoops, sorry about that. Okay. So we've got this one. All right. Oh no. All right. Well, I suppose it had to happen sooner or later. All right. So, well, looking through it, it doesn't look too bad. For one thing, all of these, looking through all these problems, they just have to do with the coefficients. So I'm not changing any of the x's. All I'm doing is I'm just changing the big numbers in front of the x's. So even though it is still a distributive function, I'm not changing any of the exponents. I'm just changing the numbers ahead of the x variables. So we're still doing, so we're still combining like terms, but we're not combining like terms, but we're not doing anything this complicated where we're going to end up with to the 5th, to the 4th, to the 3rd. Basically, if we're starting with, there we go, if we're starting with to the 2, to the 1, to the 0, for the rest of this worksheet, we're going to end with to the 2, to the 1, to the 0, all right? So let's go ahead and get started with this. So these ones are unaltered, so they will carry through to the next step. But 2 times 3x squared is going to be, so x squared minus 4x plus 3 plus 2 times 3x squared is going to be 6x squared. 2 times 6x squared minus 2 times 3x is going to be 6x. And then 2 times 5 is going to be 10. All right, so now that we have all of this, we're basically just back to our combined like terms worksheet that we started out with at the very beginning. So I've got 7x squared. I've got minus 10x. and then I've got minus 7. And there we go. When in doubt, just read what the problem's asking for, and who knows, maybe it'll work out. Alrighty, let's see. So this one's going to be a little bit trickier, but we can work this out. 12r plus 4. So what I'm going to do is I'm going to add these. But what I'm going to do is I'm going to add them. But by adding them, what I'm going to do is I'm going to multiply everything by negative 5. By multiplying everything by negative 5, what I'm doing is whatever the sign is that it becomes, I don't have to worry about inverting it. I don't have to worry about flipping it. So in this case, it's going to be minus 15 r squared. And so what that means is that it's going to be, if I'm adding a negative, so that means it's going to be minus 15r squared. Let's see. Yeah. Oh, okay. So basically, it just means that I'm going to do plus 1 at the end. All right. I think I thought I was doing a shortcut, but I basically just made it so that I'm doing plus 5 at the end. All right. So minus 5 times plus 5 is going to be minus 25r, and then plus 5. All that work, just so I could have plus 5 at the end. Sometimes you can try to be too clever, and you actually make things worse for yourself. But all right, let's see. I've got 8 minus 15r squared, so that's negative 7r squared. Now I've got 12r minus 25r, that's minus 37r. And then 4 plus 5, well, that's plus 9. I'm glad I got that one worked out. So yeah, there's the answer. Not gonna make that mistake again. All right. Oh, okay. Well, this one's going to be a little bit different because now I have to do the distribution to both parentheses, but it's basically going to be the same. Instead of just directly copying down the parentheses, directly copying down the expression like I've done in the first two problems here and here. Both of them are going to have distributions that we're going to be moving down. So 7 times 2m is going to be 14m. 7 times minus 3 is going to be minus 21. Oh, and it's not in standard form. I gotta stop letting these things ruin my day. But 7 plus 7m squared is going to be 49m squared. And then minus 2 times 3 is 6. Minus 2 times 9 is going to be plus 18 m squared. Minus 2m is going to be plus 4m. There we go. Okay. Now I have to check the answer key after all this. I don't want to have to rewrite a supplement. Have to re-record a supplement for all these. Anyway, let's start with 49m squared plus 18m squared is 67m squared. This just does not seem right. 14 plus 4 is 18m. Then 21 plus 6 is minus 27. This just, well, I just went to one of the other teachers and I took a look at it. They agreed with me. I mean, I understand that it's not a great vote of confidence for my abilities as a teacher that I look at an answer key that I'm generating and say, that doesn't look right, but it's also important to be able to look at something and have the critical thinking skills to say, I don't know, that doesn't look good. And being able to say that about yourself and about your own work. So the good news is I know that I'm right and I know my process is right. So all right, moving on. Let's see, this one I'm just going to copy straight down. So I've got 7 times 4, which is 28p squared. 4 times 3p is 12p. And then minus 5p squared minus 4. So let's see, 28 minus 5 is going to be 23p squared plus 12p minus 4. Oh, all right then. Less stress than I thought it was going to be. Okay. Now, speaking back of stress, oh, this one isn't too bad at all. Keep this one going. So, yeah, it's not written in the final form, but I don't see it's that big of an issue. So I've got, let's see, I don't really see this as being that big of a, you know what? No. I'm gonna keep going. So I've got 4 times w plus 4 times 2w squared, which is 8w squared, plus 4 times 4, which is 16, plus 2 times 3w squared, which is 6w squared, plus 2 times 1, which is 2. So let's see, I've got 8 plus 6w squared, which is going to be 14w squared, 4 plus 4w, and then 16 plus 2 is 18. All right, we're just working through these. Aside from the one detour, I mean, I'm feeling pretty good about this. All right, 7 times 3 is going to be 21a squared. 7 times a is going to be minus 7a, and then 7 times 3 is plus 21. 2 times 4a squared is 8a squared. 2 times negative 5 is minus 10. All right, so I've got 21a squared plus 8a squared. It's going to be 29a squared. And then minus 7a. And then 21 minus 10 is 11. All righty. We're, yeah, just moving right along here. And let's see here. I've got, oops, make sure it's centered in the frame here. That bothered me too. All right, so I was looking at this like, well, where's the coefficient? What am I going to multiply this by? So you got 3k minus 4k squared plus, and then 15 times negative k is going to be negative 15. So that's, I'm just going to say minus 15. And then 15 plus 2k squared is going to be plus 30k squared. Let's see. So I've got 30 minus 4k squared is going to be 26k squared plus 3k minus 15. And there we are. And again, k squared is the only one that has 2 terms. So it's the only one that I really have to worry about working with. The other 2 are just alone, so I can just copy them straight down. And as long as they're written in standard form, yeah, that's all I really have to worry about. Let's see. All right, well, this one looks a little bit more rigorous. So I've got 14x squared minus 42x minus 14 plus, and then this is 3x squared, and then 3 times 4x is going to be plus 12x. All right, we got a little bit of spread here. So I've got 14x squared plus 3x squared. That's going to give me 17x squared. And the order that I'm starting, and it's no coincidence that I'm starting with the x squareds, working my way down, because that's how you write standard form. And so it's not just good habit, it's not just preference, it's the best way to go through and keep your thoughts organized. Once you have it in this form, then all you have to do is combine the terms, and just combining the terms in the right order, it's a real time saver. So let's see, moving on. I've got negative 42 plus 12. That's going to be minus 30x. And then minus 14. Alrighty, there we go. Next one is, got x squared minus 4x. And then plus 5 times 3x squared is going to be 15x squared. 5 times negative 3x is negative 15x. Then 5 times negative 5 is minus 25. All right, again, the biggest number exponent is going to be x squared, so 15x squared plus x squared is 16x squared. Then I've got, next one is just going to be regular x, so I've got negative 15 minus 4 is going to be negative 19x. Then plus 3 minus 25 is minus 22. And there we have it. Ooh, all right. Okay, just look at this last one. Throwing us a couple negative signs there. All right. So negative 4 times 12 is negative 48r. Negative 4 times negative 4 is negative 16. Minus 3r squared. Minus 5r. Plus 1. All right. Let's see. So 3r squared is the highest polynomial, and it doesn't have anything else. 48 minus 5 is 53. And then negative 16 plus 1 is minus 15. And there we go. So yeah, so remember when you're starting out and you're doing the distribution, that if you have a number on the outside of a parentheses, that you have to apply that number to every single element within the parentheses. And then once you have it worked out, then once you have that done, you combine then once you have that multiplication done, you can combine like terms. Well, you really more combine the terms if you're on this side of the worksheet. But if you're on the other side of the worksheet, just make sure that you write it in standard form in descending order with your polynomials. And yeah, it's a lot of it's basically just practice and then adding a couple exponents. But yeah, practice makes perfect. Let's keep it going.